Hello, this is Mrs. Brown, and we're working on applying the quotient rule. So, as we take a look, remember that if you have powers with the same base, that you can subtract their exponents in order to simplify. So let's start looking at some examples. 7 to the 5th divided by 7 to the 3rd, that would be the same as 7 to the 5 minus 3, which would be 7 squared. Again, you can't leave it like this. You actually have to simplify that. And so 7 squared is 49. So your final answer would be 49. If I have m divided by m to the 3rd, remember that we talked about the fact before that if it's just m, that's the same as m to the 1st. So don't forget that. And you're going to do the same thing, m to the 1 minus 3. Well, that's m to the negative 2. Now, here's the rule. When you're simplifying, you can't leave a negative exponent. Well, you already learned about negative exponents. It just means that it's in the wrong place. So if you set it up like a fraction, right now it's in the numerator. It just needs to be in the denominator, and once you move it, it's positive. So it's just going to be 1 over m squared. So the final answer to this question, to have it completely simplified, would be 1 over m squared, because we're not going to leave the negative in the final answer. Okay, so let's look at some more examples. X to the 9th divided by x to the 3rd. Okay, again, bases are the same, so x to the 9 minus 3 is just x to the 6. Since it's not a constant, I don't actually have to calculate it. That's my final answer. Okay, let's say I had 12 to the d to the 4th divided by 4d. Now, remember that when we did the power rule and the product rule, for instance, if we had a coefficient, we just treat them like we normally did. So for the product rule, we just multiply them together. So in this case, you're just going to divide these. You're going to simplify it like you normally would with a fraction. So 12 divided by 4 is 3. Since it's a 3 and not 1/3, the 3 goes in the top. And then I'm going to do d minus, and again, d to the 4th minus d to the 1st. I'm taking the exponents and subtracting them in order to do that. So d to the 4 minus 1, which would be d to the 3rd. I don't actually have anything in the denominator, so my final answer would be 3d to the 3rd. So again, treating this like d to the 1st, and it's just 4 minus 3. 4 minus 1 is 3. Okay? Sorry, misspoke there. All right, so let's look at a little bit more complicated. Not too bad. We'll get into the more complicated one in a minute. All right, so let's take this in 2 steps. Okay, 15/45, if you had that as a fraction, no variables, you would simplify that. 15 goes into both of those, goes into 15 once, and it goes into 45 3 times. So that simplifies to 1/3. Now let's deal with these. And I'm going to go down here to deal with these. N to the 2 minus 5, because it's 2 minus 5. You can't change the order of subtraction. So since this is in the numerator, I'm using that one first, which means it's going to be n to the negative 3rd. Well, the n to the negative 3rd is going to be up here. Okay. Well, what do we know? We're not allowed to change it or leave it as a negative, so we're going to change it. And all we're going to do is flip that into the denominator and make it positive. Okay. Again, the negative in an exponent doesn't mean that it's a negative number. It means it's in the wrong position. It has a different meaning when we're talking about exponents. So if it's in the numerator, it has to go to the denominator. If it's in the denominator, it goes to the numerator. All right, let's look at another example. All right, so we got 36, x to the 3rd, y to the 5th, z, divided by negative 12, x, y squared, z. Okay, again, when you have a variable that doesn't have an exponent, that exponent is 1, we just don't write it because we don't need to, because x to the 1st is the same as x, and z to the 1st is the same as z. All right, so taking it step at a time, 36 divided by negative 12 would be negative 3. Okay. X to the 3rd minus 1, so 3 minus 1 because I'm dividing it, is x squared. Y to the 5th divided by y to the second is the 5 minus 2. And so that would be y to the third. And z to the first, so 1 minus 1 is 0. And of course, z to the 0 power is the same as 1, so it goes away. So my final simplified answer, oops, that was a 2, would be 3x squared y to the third. Because again, z to the 0 power is 1, because anything to the 0 power is 1 except for 0. Okay? All right, let's take a look at a few more negatives and dealing with negatives. Okay? So negative exponents. Okay? 4 to the negative 2 just means that, hey, this is in the wrong position. It should be 1 over 4 squared. And since it's a number, we actually have to evaluate it. 4 squared is 4 times 4, which is 16. So this is equivalent to 1/16. Okay? If I have something like 2/3 to the negative 2, okay? This is inside parentheses, so it applies to both the numerator and the denominator. And what this is telling me is find the reciprocal and then square it. So this is 3 squared over 2 squared. So I find the reciprocal, so I'm flipping it, because the 3 should be in the numerator and the 2 should be in the denominator. And then I actually have to calculate it because it's numbers. Okay, so I evaluate it to simplify it. So that would be equivalent to 9/4. Again, the negative sign in the exponent just means it's in the wrong position and you have to flip it. So if it's a fraction, you're literally just flipping it over. All right, last question. Let's take a look. M to the 0 times m to the third times m to the negative 4. Okay, when you take a look at this, this is actually the product rule. So m to the 0 is 1, so we can just get rid of it. But if you want to add it in, this is 0 plus 3 plus negative 4. So this would be m to the negative 1. I can't leave a negative in my answer, so this means it's in the wrong position. So it needs to go to the denominator. And that would be it. Okay, I hope this helps. Have a fabulous day, and I will talk to you soon.